Hello everyone, I'm Rachna and currently studying a third year of Computer Science and Engineering at Bangalore Institute of Technology. And in this video, I'll be demonstrating how to design a DFA using JFlap to accept strings of A's and B's that end with either AB or BA. Let's get started. So first we should download the JFlap software from their official website, and here I'm going to download JFlap 7.1, which is the latest version of the JFlap software. Once it is downloaded, on double clicking the downloaded file, we will get the list of things we can create using JFlap software. So since today I'm creating a DFA, I will choose finite automaton. And so first, let's look at the problem statement. The problem statement states that we should design a DFA over the alphabets of A and B such that the string must end with either AB or BA. So first, let's look at the minimum strings we should accept using this particular machine. I'll add a note and I will write the minimum strings. The minimum string will be AB and BA. And coming to the strings of length 3, which should be accepted by the machine. We will have A, AB, we have B, AB, we have A, B, A, and we have B, B, A. So this is for strings of length 2. This is the minimum string, and this is strings of length 3. So first, let's start designing of the machine using the initial state Q0. So first, I've put a state which is called as Q0. And now to make any state as the initial state, we should go to the attribute editor and we should right click on the state and we should mark it as initial. Okay, so now we have a state which is the Q0, which is the initial state. Now to accept the minimum string of AB, we will take a path from Q0 to accept A and B. So I will take a state Q1 and a transition from Q0 to Q1 on A, and I will take another state Q2 and I will give a transition from Q1 to Q2 on B. So when the string which is to be processed by the machine is AB, so first Q0 will process the string A and will go to Q1. Q1 will process the string B and will go to Q2. And to accept AB, we should make Q2 as the final state. So again, we will go to the attribute editor, we will right click on Q2 and we will mark this as the final state. So from this, AB minimum string will be accepted. Now to accept BA, I will take another state Q3. I will give a transition from Q0 to Q3 on B, and I will take another state Q4 and I will give a transition from Q3 to Q4 on A. So from this, the minimum string BA should be accepted. So when the string which is to be processed by the machine is BA, Q0 will first it will process the string B and will go to Q3, Q process A and go to Q4. Now to make Q4 as the final state, again we will go to the attribute editor, right click on Q4 and mark this as final. So both of these are done, AB and BA, both of them are done. Now to accept strings of length 3, first we have AAB. So if we see here, only AB is accepted. To accept AAB, we should give a transition for Q1. And Q0 already has a transition on both A and B input symbols. Q1 has a transition on only B. So now we should give a transition for Q1 on A. So here we will give a self transition for Q1 on A, because A followed by 0 or more A's and followed by a B should be accepted by the machine, because it will be a string which will be ending with AB, which fits the problem statement's requirements. So we will give a self transition for Q1 on A. So from this, AAB will be accepted, because when the string is AAB, so it will go from A, so on processing it will go from Q0 to Q1 on A. On Q1, A will have a self loop and B will go to the Q2, which will be the final state. Now for ABA, for the string BBA, So here we have a transition for BA already. So since Q3 has a transition only on the input symbol A and it does not have a transition on input symbol B, we can give a self transition for Q3 on B so that Q3 accepts 0 or more B's. So any string which has B followed by 0 or more B's followed by an A will be accepted by the machine since it is ending with BA, which satisfies the problem requirements again. So here I'm giving a self transition for Q3 on B. So AAB is accepted, and for BBA, when the string to be processed is BBA, the machine will go from Q0 to Q3, it will again be in Q3, and next will go to Q4, and the string BBA will be accepted. So here AAB and BBA, both of them are accepted. Now coming to accept the string BAB, there is no transition for Q4 on the input symbols A and B. To accept BAB, the Q0 will go from B, we have a transition on A, there is no transition for the input symbol B. To accept BAB, it should go to a final state, and Q2 is also a final state. So we can give a transition from Q4 to Q2 on B. So we'll give a transition from Q4 to Q2 on B. So here now BAB will be accepted when the string is BAB. Q0 will process B and go to Q3. Q3 will process A and go to Q4. Q4 will process B and go to Q2. So now BAB is accepted by the machine. Now for ABA, we should give a transition for Q2 on the input symbol A. So when it is ABA, we should give the transition for Q2 on the input symbol A to another final state, and the other final state is Q4. Transition for Q4, and we will also not give a self transition for Q2 on any of the input symbols because the strings which is ending with AA or BB should not be accepted by the machine. If we give a self transition, then that means that it can take a 0 or more number of that input symbols as the ending string, substring. So now coming to ABA, so first A, B and input symbol, or for the input symbol A, we will give a transition from Q2 to Q4 on A. So Q2 to Q4 on A. Okay, so now so for Q2 there is a transition on A, there is no transition for B. So now to give a transition on B, so first let's make a list of strings of length 4 accepted by the machine. So first we will have A, B, next we will have B, B, next we will have A, B, next we will have B, B, next we will have A, B, next we will have A, B, and B, A. So that will be 8 different strings of length 4 which should be accepted. Now let's see if our machine is accepting the string, accepting all of these strings. So first we have 3 A's followed by a B. So first on seeing the string, it will go from Q0 will go to Q1 on A, and Q1 will accept the second A, the third A, and on encountering the input symbol B, it will go to Q2, and since Q2 is the accepting final state, it will be accepted. Now for BAAB, so now Q0 will go to Q3 on B, on A it will go to Q4, next on another A, there is no transition for Q4. Q4 has only a transition on B and it does not have a transition on A. So we have to give a transition for Q4 on A, and the string to be accepted is BAAB. So we'll give a transition from Q4 to Q1 on A to accept the string BAAB. So from Q4 to Q1 on A. So now for the string BAAB, so Q0 will go to Q3 on B, Q3 will go to Q4 on A, Q4 will go to Q1 on A, and Q1 will go to Q2 on B, and since Q2 is the final state, it will get accepted. So that is also done. Now for ABAB, so first A, Q0 will go to Q1, Q1 will go to Q2 on B, Q2 will go to Q4 on A, and Q4 on B will go to Q2, which is also a final state. Now for B, B, A, B. So first for B, Q0 will go to Q3, and for another B, it will remain in Q3 on processing that. And next we have another A, so it will go from Q3 to Q4, and for the last B, Q4 will go to Q2, which is a final state. Now for A, B, A. So we have A, B, A, that is also accepted. Next for B, A, B, A, we have B, A, B, A, that is also accepted. Next we have A, B, B, A. A, B, there is no transition for Q2 on B. So we'll give a transition from Q2 to Q3 on B. So here we are giving a transition from Q2 to Q3 on B because Q2 already has a transition on the input symbol A and it does not have a transition for the input symbol B. So since if we give the transition to Q3, it will accept the string of A, B, B, A. So here if we see for A, B, B, A, it will go from Q0 to Q1 on A, Q1 to Q2 on B, Q2 to Q3 on B, and Q3 to Q4 on A. And since Q4 is the final state, it will be accepted. And next we have B, 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 A. So it will go from Q0 to Q3 on B, and it will loop over the other two B's, and for A it will go to Q4. So all of these are completed, and this is the complete machine for accepting strings of AB, which is ending either with AB or BA. Now to test for the input, we will give an input of which will get accepted and another case of which will get rejected. So first let's give a string of length 5 which is ending with AB. So here I am giving AB, AB, and I will click on OK. And now I will select step to step over each alphabet which is present in the string. So first it will be in Q0. On processing A, it will go to Q1. Next, for the next symbol is another A, so it will be in Q0, Q1. It will self loop over Q1. Next for B, it will go from Q1 to Q2, and Q2 on processing A will go to Q4. Q4 on processing B will go to Q2. Since Q2 is the final state, it is indicated by a green symbol saying that the string will be accepted. Okay, so now to give another input symbol, input string. So here I will give a string which should be rejected by the machine. So I will give a string of length 6. So I'll give A, B, B, A, A. So here it is ending with 2A, so this should be rejected by the machine. So first let's see, on A it will go to Q0 will go to Q1, Q1 on A will self loop, Q1 on B will go to Q2, Q2 on B will go to Q3, Q3 on A will go to Q4, Q4 on A will go to Q1, which since it encounters the end of the string and it is not in the final state, the string will be rejected, which is shown using the red color in the JFlap software. That's it. So this was the problem and the simulation for the DFA to accept